This is question number 5, which is hopefully a familiar formula to you for adding resistors in parallel. So the R on the left-hand side here, it usually represents the total resistance RT of two resistors in parallel. And for this particular one, we're asked to get RT on its own. What I'm going to do is go through this, and what I'd then like you to do is to have a go at to get the formula for R on its own. So the procedure, probably the most straightforward procedure for doing this, is for each of these terms here, 1, 2, 3, multiply through by R to get rid of R underneath in that term, multiply through by R1 to get rid of the R1 in this term, multiply through by RT to get RT in this term, and then have a look at it again and see what to do. So try that out. I'll go through it below. If I multiply through by R, 1 over R times R is just 1. R over R1 plus R over R2. So that's multiplying through by R. Now multiply through by R1. R1 times 1 is 1. R1's cancelled in that term. And R1 times R over R2 is that term. Now multiply through by R2. We get R1 R2 equals R R2 plus R1 times R, which might look awkward, but at least there's no denominators now, and that's a common little trick to do that. Multiply through by the denominators. Now remember, I'm after getting R2 on its own, so let's get all the terms in R2 on the same side. So subtract R times R2 from both sides. You get R1 R2 minus R2 equals R1 times R. Factorize. It's again a common thing to do when R2 occurs in two terms. Get them on the same side and then take them outside a bracket. R1 minus R equals R1 times R. And now finally divide both sides by that term in the brackets. R2 equals R1 times R over R1 minus R, which is the solution in the text. What I want you to do now as an extension is to take this formula plus 1 over R2 and rearrange it to get R equals something. Rearrange the formula for R, make R the subject. Following a similar procedure to what I've just done. I'll stop the video here, but then carry on and put the solution if you want to have a look at it.